welcome Mr. Cedric Champeau, the author of JSolEx. And hello,
Hello, hello.
hello. Okay, you have the stage.
Okay, excellent. Yeah, so first of all, thank you, Ming, for organizing that, especially for you, it must be super late. So I guess, yeah, you won't have much sleep tonight.
Okay, thank you.
And yeah, thank you everyone for joining. So basically, the idea of this session is to present the basics of JSolEx, but also show you some, yeah, FAQ somehow, like show you in action the software, what it can do. So even if you're not familiar with that, yeah, you should be able to do something with the software after that session. Also, I have prepared some demo scans, and I just need to find a way to upload that somewhere because it's yeah, 20 gigabytes, so quite large. So basically, the idea that if you want to try this later, you can basically use the files that I have. So even if you don't have an SAG right now, you can still play with the software. That would be the idea. Okay, so let me share my screen now. And yeah, if you have questions, yeah, drop them in the chat. I guess you can ping me if there's a question that
Sure.
I can answer. Because I will probably be focused on sharing, so I will probably not see the questions. Okay. So first of all, just yeah, a bit of history about JSolEx. So basically, the project came out as an accident. Like a couple years ago, I started doing some SAG work with SolEx, and my background is that I'm software developer. And when I was trying this SolEx, so this is the spectral graph that was created by Christian Buil, and I basically had no idea how this thing was working. So it was kind of magic, like you take some picture of the spectrum, you take a video, and then at the end you get this reconstructed image of the solar disk. And that was kind of a miracle to me, but I had absolutely no idea how this was working. So because I'm a software developer, I decided to take a challenge and understand how it works by implementing my own software to process the images that were produced by this SAG. And yeah, it came a long way since then. Had many different versions, and more and more users actually of the software, and eventually more users of people who were not using the SolEx but different SAGs like the one from Mean. So yeah, it became quite popular, and yeah, I thought it would be a good idea to give an intro so that people can understand basically the differences between this software and typically Inti, which it is inspired from in the beginning. And there's also the software from Duke Smith, which I think he's in this meeting. Yeah, so no pressure for me. All right, so yeah, that's for the history of the software. So basically, if you want to install it, I just released a new version today, of course, for this meeting. So there's the latest is 3.3.0, and you go to this page and you have a few download links. So you have a version and installer. So basically, you have some installers for Windows, Linux, Mac. And if you prefer something I added, it was still possible before, but it was complicated to find the links. But you can also just download the zip file and zip that into the directory you want and just use that version. So it's actually required for some people, especially on Linux. You have some distributions which are not supported. So in this case, just download the zip file and zip that and run. And here we go. So the software comes with a comprehensive documentation. I hope so, at least. So everything that I'm going to explain in this meeting is basically explained also in this documentation. But if you find some things which are not clear or that you want me to document better, don't hesitate. So you have everything at hand here. And I thought that it would be actually better to show you the software in action rather than read it in docs. I think you basically prefer that, right? So let's get started. So when you open the software, it basically looks like this. So it's a window, and you have just one idle menu, like open a surf file, and you would basically select the surf file that you want to process. So in this case, I'm going to process some files which were acquired using the SAG 700, and I'm just selecting this, and then you have a basically a window with some options. I'm not going to explain the options right now. I'm just going to go through the quick mode just to explain what it produces. So you see that it basically reconstructed the disk, and then you have some images showing up. So the interface looks like that, and the idea is that you have on the left all the different images that the software can reconstruct, and then on the right you have some helpers. So obviously you have the logs and some other topics I'm going to explain a bit later. And basic controls, like if you click on control and then move on the mouse, you basically can zoom in, you can move the window, and then you have the usual fitting so that you can actually see what's going on. You can rotate if you want to, etc., etc. You have the correction of the P angle if you want to apply it, which is deduced from the date the video was taken. And then you have some sliders like to do some contrast enhancements if you want to, knowing that basically this disk is pre-processed, so you can basically choose what you want. And you have different options. So one is basically to do no stretching. The other one is the linear stretch, which is the default. And one last is curves stretching, which is a bit better, I think, than the linear one, because this one would never saturate anything. So it would just apply a curve to the levels, so increase the different levels of intensity without never going to cut any kind of data. So this one is the one that I did in a recent version of JSolEx, and I think it's actually much better than the other one, which is the linear one. So I'm probably going to switch the default in a future version. But let me know what you think in any case. So something important in the interface is that you always have some information at the bottom, which basically explains what you are seeing. So this is something that I want to do in this software because it took me some time to understand how this spectrograph thing is working. So I'm trying to do the same education work to users by adding some documentation inline in the software. So basically here it tells you that this image was taken using image at pixel offset 0, and we're going to see what it means. And then it has some geometry correction applied, and then some auto stretch strategy, which is the default that you would get. However, if we go to this one, which is the solar disk, it basically tells you that this one is the result of the reconstruction, again with pixel shift 0, but then it has absolutely no contrast enhancement at all. So what you see is basically the result of a single scan, but just with the geometry correction applied, and that's it. So this is something which is basically what you would like to use if you want to use external software to process your images. So the philosophy of JSolEx is basically that you have a number of images that are going to be generated for you, and I try to make them as appealing as possible, and not too over processed or whatever. But basically, you also have the option to take these out of the box and process them externally. And the reason I do that is that basically, as a developer, I'm lazy, and what I want to do is that I want to avoid personally using too much external software. So all the images that I'm basically publishing on SoraChat or whatever are entirely processed using JSolEx. So I never use AutoStackit, I never use GIMP or Photoshop or whatever. Everything is done within the software. So this is what I do, but it doesn't prevent you from having the idea of doing that externally if you want to. Of course, yeah. But it's worth saying that my personal philosophy is to do that within the software. So let's look at another thing that I added recently, and because I'm using this interface, I can click here, and you have this solar ruler, which is basically added, and it's basically showing you the disk with the distances, and you can click on like this region to measure the filaments. So I can double click here and then draw something like by adding some clicks, and it would measure the size approximatively of the filaments that you want to highlight. And then you have this version like the solar ruler. And in this case, because it's using the non-stretch image, it's not very clear what the prominences are. So the idea is that you can actually use different images to have something more visible. So that's what I'm going to do now. And I'm going to just go to the recent files and reprocess this file, but this time I'm going to use full process to show you more images that we can generate with JSolEx. So it's still very fast to produce this, but now I'm going to go to this virtual eclipse that you have here. And you see this image, it's much more appealing just for the prominences, and I can still click on that, and then you will have something which is more interesting if you just want to measure these prominences. So this one was quite huge, and it's just from a few days ago, like 150 kilometers high, which is pretty crazy. So yeah, just basic tooling to do you some nice images. But so now that I've selected the full mode, basically you saw that the processing is slower, and it's just because it's generating everything that JSolEx is capable of doing out of the box. So you have the two images that we saw before, but now we also have additional images like the continuum. So in this case, we just take the image, but we shift from 0 pixels to 15 pixels, and I'm going to show you what it means in practice. And then you have same with the contrast enhancement applied. And again, we can zoom in and see. So this is a single scan. It's not that bad for a sunspot to have that kind of details here. And typically what I can do is just click on this button here, and it would align all the different images that I have on the same location. So I can compare now the different images at the same position. So something which is interesting if you don't know exactly what this button is doing, magic button. Then we have active regions, and active regions is basically the software detecting active regions automatically directly from the spectrum. And that's why you have two different colors here. So one is blue and the other is red. And the reason you have two different colors is that for blue, it means that JSolEx found them directly on the spectrum. Like by analyzing the different frames, it was able to basically recognize that there's an active region here. So again, if I click here and go to the active regions, but this time in the continuum, you would see that it has highlighted this region automatically. And then you have the red labels, and basically these are fetched from an external database, so the SRS database, and it basically tells you that JSolEx in this case was not capable of seeing that directly on detection. So depending on your images, you may or may not detect some areas, and this one is interesting too because we can see that we have sunspots which were detected by the software but were not in the database. Yeah. So before I go with the next images, I'm going to show you something which is actually quite useful, because here I have some doubts, like how do I know that my image is oriented properly? Because the detection of these sunspots actually requires that the orientation of the image is correct in order to put the labels at the right places. Like it fetches the data from SRS, and then it needs to map that to whatever image you have. So if it's not oriented properly, you would basically have red everywhere instead of blue and potentially red. So the way you do that is actually very simple. You go like in this image, which is H alpha, and then I would go to this additional tab here, which is Gong, and then I would click on this download reference image. And what it does is that it takes an image from Gong, and then we see that it is oriented properly. If it was not, what I could do is basically apply the reverse, like mirrors, rotations, whatever, and then do, okay, I need to do this now, it's still not right, and I probably need to apply the P angle, and there's a vertical flip, so let's do this, and now I'm correct. I have oriented my image correctly, and now I'm going to click on this button, and next time I'm going to process my image, it's going to reuse those parameters. So basically the idea would be that you take a first image, you look at the Gong reference image, you oriented that, you click on this button, and then the next scans that you're going to do are going to be oriented properly. So because it's fairly easy to forget if you need to apply a vertical mirror or not, etc., etc. So this is actually yeah, super practical to do that. And once you have done that and the orientation is correct, then and only then you can make sure that this guy, the technical card, is oriented correctly. Because if you don't do that, basically you would have mirrors, and yeah, this grid would not be what you would expect. So just, yeah, be careful. If you haven't done the orientation properly, this technical card is going to be wrong. So yeah, this is an error that we often see in the wild, so just warning, because it's super important. Of course, we have some images like the what you see, like the Doppler effect, and that was something that INTI typically was doing, and then I added after that something like the Doppler eclipse, which is actually very nice, because then you can see something that you would not see if you were just on this version, like the virtual eclipse. Like you just see the prominences, but you don't see the movement of the prominences. And if you go with the Doppler eclipse, actually, you can see that some filament is bluish, so it's actually going in our direction, despite the fact that in this image, it's the on the right side, it's basically the sun rotation, so it's moving away from us, but these prominences were actually moving towards us. So super interesting to see. So there's lots of things that you can do like that, which are, I think, super interesting. And again, I will always encourage you to read the description of the different images, especially in the beginning, to understand what you're seeing, because the fact that you have blue and red depends on the orientation of your scan and how you have set up your SHG on your telescope. So in the typical use case, you should see something like this with the blue on the east and the red on the west. And if it's not the case, then you should have something like this, like checked, which is basically switching the red and blue channels, because the software cannot determine whether it's oriented properly or not. So just make sure that you have this checked properly. Otherwise, yeah, it's just a convention to have the blue and the red, but you should, yeah, try to get it right, because that's what people expect, basically. So in terms of interpretation, it makes more sense to have this. And okay, so more images that we have. Obviously, some people really enjoy the colored images. So there's a colorization by default in JSolEx based on the wavelengths. of what you're observing. However, for H alpha, it's actually something different because if we were to colorize in H alpha, it would be red, like full red, and it's not super nice for the eye. So this is the exception. In this case, it's not based on the wavelengths, it's based on artificial coloring that you can change if you want to also. So there's a menu here, and you have something called the Spectral Rays Editor. And if you go to H alpha, then you can potentially change how you want to colorize the different things if you want to. But if we deactivated that, it would be red, see? So it's just a matter of taste. Personally, I don't share many, if ever, colored images because I find that the details are a bit lacking compared to the monochrome versions. But yeah, whatever you like, that's the principle. Like if you prefer sharing these, do that. And then because this is software which is not just for having nice images, but also trying to do some science, there are some phenomena that I'm going to talk about after, because before doing that, I need to explain this concept of pixel shift. Maybe you're not super familiar with that, so this is something which is worth introducing. So if you remember when I was talking about this process sonar disk, basically what it tells you is that it's at the pixel offset 0. And we need to understand what this 0 means. And then there was the continuum image. And in this case, I hope that this is visible for you, but there's this plus 15 there. And basically tells you that it's 15 pixels off. But off what is the question? So for understanding these, I'm going to go to the reconstruction tab and click on reconstruction here. And I'm going to click on wherever I want in the disk. So say I click on this filament. When I do that, it actually moves and tells you in your original surf file where this particular pixel comes from. So in this case, if I zoom in, and let's say I'm selecting something here, I can see that I'm close to some sunspot. And if I move a bit on the right, I am right on a sunspot here. So that dark vertical line is a sunspot. It's not necessarily obvious when you look at the H alpha version, but if I move to the shifted version, we can see that it corresponds to this sunspot here. So if I go there and click here, and then we see, let me zoom in a bit more. We see that when I click there, this red cross here is no longer in the middle of the dark line, which is the H alpha line. It is shifted by 15 pixels. So it's 15 pixels up. So it's exactly what this pixel shifting concept means. It is basically that you take the H alpha line, in this case, which is the darkest line in the cropping window, and then you take the pixels which are shifted by 15. So this is really something that I find this tool is really interesting if you want to explain how an SAG works. Typically, if you do a public event and you have this instrument and you want to explain to people how this works, it's something which is, I think, interesting because you can show in practice, oh, you see that dark line here, it corresponds to sunspots. And then you can click on something else and you see nothing. And then you move there and you go on the filament and you say, oh, it's strange because this filament doesn't show up as a dark line, but actually it's if you zoom really, really into something, you would see, and it's probably difficult for you to see that with the zoom and on your screen, but the signal here is not totally black. Like there are some variations in the signal, and this is exactly where we are getting the signal to reconstruct the image. It is in the middle of this line. So everything that we reconstruct comes from the center of this H alpha line. And when we're building a Doppler image, basically what we do is that we take two images, like one shifted by a few pixels up, the other by a few pixels down, and then we reconstruct an image based on these two different shifted images. And this gives us this Doppler image, because if we zoom in even more and we look at this, we can see that the line is actually not perfectly straight. It has some movement in here. Here it's visible, so there's some widening and then narrowing depending on the location on the disk. And this is a typical effect of the Doppler shifting. And this is also, by the way, something which is important for focusing. So it's a focusing hint. If you see that with the eye, when you take that with SharpCap, it is that you're close to the good focus. And probably you see also that there are some dark vertical lines which are not as deep as a sunspot and not as wide as sunspot. And these are also a good hint that you're at good focus. If you see these in H alpha, it means that you're basically at good focus. Then there's this dark line which is here, and it's actually present in all the different frames that I have, and the reason is basically that this is dust on the slit. So I have a dust particle on the slit. It's not catastrophic because you can see that the software is going to get rid of these in the final image. So it can deal with that. And it can actually be useful also as a focusing hint. So it's not necessary to get rid of all the dust if you have some defects. If you have many dust particles, then you should, but one is probably okay. And how does the correction work? So there's in the process parameters here, you have different options, and then there's this image enhancement. And here you can see that we have a bending correction. So it basically takes a width of correction and a number of passes, which is huge in this case. You don't need as many passes. You probably can reset to the default. So the default is 24 and 4. And basically, if you see these lines and that the correction is not applied correctly, you still see them in the produced image. You can play on these parameters, like the width of the correction and the number of passes to get rid of these. So in the beginning, I would just encourage you to use a low number of passes, and just try with that, because overcorrection is never good in any case. So now that we understood what these lines mean and what the pixel shift means, we can actually understand more a bit what is going on in the last section, like the detected phenomena. And in this case, we see that we have some movement on the line, and this corresponds to a speed in terms of Doppler shifting that we can compute. So JSolEx is actually computing automatically finding on the spectrum, finding where the shifting is highest. So in this case, we can see that there's some movement here. The detection sees that there's a movement of the HFL line that goes down to here. Maybe it's not super accurate. So again, read the docs, because it tells you exactly that. It's not because you see something that tells you 200 kilometers per second that this is actually a phenomenon that corresponds to that. You should always check what the software is producing. And it tells you, at this location, you have this phenomenon going on. Then you have another one. So let's look at that. Let's zoom in again. And again, we have some, good shifting here, etc., etc. So we can see these detected speed somehow. And then you have this image, which basically locates that on the disk, which can be quite useful and helps you figure out if it makes sense or not. And so currently JSolEx detects just a few number of phenomena, and I want to add more as I personally learn on what we can detect on the spectrum, and that's why I basically keep most of my scans. So I have more than 1,000 now, so take some disk. to do that. But basically, if I look at the phenomena which are detected in this particular scan, we have the speeds there, and then we have this phenomenon called an element bomb. And I can look at this, and if I zoom in, we're going to see something special here. So it's subtle, and I hope that you see that there's a subtle line, and it's called a mustache. And it's basically a brightening of the line outside of the H alpha line. So it has detected that automatically, and it corresponds to what is called an element bomb. And again, it would tell you, hey, look here, you have something happening. And if we look at the continuum, you can see maybe, and I hope that you're going to see that, there's a bright spot here. There's a bright spot, and that bright spot corresponds to the bomb. But it disappears when we are in the middle of the H alpha line. So this would be typically only visible on the continuum, so on the plus and minus sides, so on the not directly in the middle of the line, but I can actually highlight that more precisely by doing like a control click on this region and ask JSolEx to create an animation of this region. So when I do that, let's do a wider, like 250. I can ask it to basically show me what is going on at different pixel shifts, and there it's expressed in pixels, but in below you can see that it's also expressed in angstroms. So in this case, I can basically tell it, and I'm going just to do that for now, like 20 to 20, so 2 angstroms towards red and 2 angstroms towards blue. And it's going to reconstruct different images at different pixel shifts and create directly an animation of this. So if we go to the logs, we're going to see that it's working. It's going to take a bit of time because now basically what it needs to do is to reconstruct the same image but several times in order to generate an animation which is going to show at a particular instant in time. So it's not going to be an animation in time, it's going to be an animation at a specific time moment. And what we're going to see is different pixel shifts, and in practice, it corresponds to different altitudes in the chromosphere. So what we're going to see is that we're basically moving in the chromosphere and seeing different phenomena there. So hopefully this is not going to take too much time. It's going to be completed soon, I guess, now. I have quite powerful computer here, so but still Zoom is taking some time, CPU. So while it's doing that, I see that I have questions. Please show the element bomb. Here it is. It is. So I'm going to talk about the jagged edges function after, but we're not going to discuss that. So it's going to complete now. Oh, actually I have this already created. So it created a panel, and then you can see that we have, oops, let's move to this. So we have a panel and it shows different angstrom pixel shifts and then a corresponding speed, and then we can see what's going on here. But in the animation, it's often easier to see that as a video. And then you can see that we're moving, and there we have our element bomb, which is here. It's actually easier to see as an animation, and it disappears when we're just in the middle. So if you look at this, when we're close to 0, it disappears, but then in the continuum, it's visible. And that's typical signature of an element bomb. So again, if it tells you that you have something like that, you should look at the spectrum to see if it's actually true, because there will always be some false positives. And typically, if we go there and that you see element bombs on the limb, it is a defect that exists today in JSol'Ex. Like often you see detection on the limb, but it's not element bound. So just be aware of that. But the right way to check is just to look at the spectrum and see, okay, this looks like one or not. That's basically it. All right, so let's look at more data now. So I can go here and talk about the different tabs. So basically you have one which is just a histogram, not much interesting. Metadata, I won't go on this one, but this one, so the profile is interesting because basically what you have is a representation of the profile data, and you have different data here. You have data, so how the spectrum should like if you were on H-alpha, so that's the reference intensity, and this comes from the BAS2K database. It basically looks like that. And then you have your profile. So the closer it looks, the better it is. And often it doesn't quite happen with the SAG 700, but typically if you use the JSol'Ex and that you over expose, you will have some flat lines on the edges, and that's not good because you basically saturate the continuum. So you want to avoid that, and seeing the intensity and the detected intensity is a good thing. And then if I click here, basically it basically changes the when I click on something in the graph, it basically shows me how the particular intensity shows up, and that's super interesting. So you see that here I clicked on a region of the spectrum where there's some high velocity thing happening, and we can actually see that directly on the profile. So yeah, you have data that you can use if you want to do some science. I'm not saying that you should do, but if you want to, you can extract some interesting information, and then you right click on that, say, oh, I'm going to export that to CSV, or I'm going to open in a new window and explore that and save that to a file if you want to. But then you have the malformation of the H-alpha line due to Doppler shift, which is clearly visible on this one. So I think that's an interesting thing to see. And then this last one is basically a way. So I've shown you how you can basically generate animations and whatnot from directly an image, like selecting a region and clicking on create animation. But you can do the same directly from this if you want to, like it knows the positions directly. It's just that if you do that from the disk, you can more precisely select what region you want to do. And then something I added just in the version for today. So for that, I'm going to open another file. So I'm going to go to Curiosity because yesterday I had a very strange phenomenon and I was not able to explain what was going on. So I'm going to show you that. And if there are some people into science and whatever, they could potentially tell me what is going on. I have the beginning of an explanation, but it's not clear. So so here there's something happening in this region. I'm going to go to the continuum image and it's more visible. So there's this small thing visible here, which is not a sunspot. Like it is visible in the continuum and it should not in practice. So if we go there, it corresponds to a region of the disk like here. And if we click on this region, something is going on. Like I'm going to zoom again. Yeah, let's move that. So you see there, something is super fishy. Like something is really strange. And what you can do now is that I can go to the continuum here, select this region, and click on extract the corresponding frames. Ooh, I have a bug. What happened? This should not happen. That's the demo effect, of course. Maybe I've done something wrong in terms of rotations. No, that should be okay. Okay, that's what I tried this just before this meeting. It was working. Anyway, so it's supposed to extract.
Maybe cropping, Cedric?
I'm not cropping, no. I want to
I
extract.
think you are cropping at 1.2x.
I'm cropping it 1.2. Yeah, I am, yes. But it should not matter. Like auto crop is, yeah. By default, I suggest, by the way, that you do that. Like always use auto crop. But I could do that. Let's see. That's the occasion to show you another button. Like if you don't like all these images, you can select custom process and select precisely what you want. So in this case, I'm going to select geometry corrected image and continuum, ask it to generate that. So I have a bug to fix, yeah. And I'm going to this region again and extract. No, there's something that I broke just before this meeting. Of course I did. Missing start center. I don't know. This makes no sense to me. Anyway, the idea was to basically extract from the video. So I'm going to fix that. But that's the occasion to show you the other tool that I use, like the video analyzer. And if I go to this guy, and I'm going to select reconstruction, it's going to tell me which frame it corresponds to. So I'm going to go here and click. It says it's frame 2K. So let's go here. And now I'm going to select frames and select frame 2000. And then we see the phenomenon going on here. So let me increase a bit because I'm capturing with just the gain 0, so it's not super visible. But if I move 2K, sorry. If I move the frames, so I have to do that manually, or maybe should, yeah. You see the phenomenon going on here. And it was quite impressive, you see. Just 100 frames between these two. And if we do that and go here and create an animation, it's quite impressive what we see. So I can create an animation. Why is it broken? It worked a few minutes ago. I don't know. I created an animation. Anyway, I can show you that actually there because I have that on AstroSurf because I created the video just earlier. So let's move there. And we have this guy, and this is what we would see. It's supposed to generate this. So quite impressive. So something is really going on. And the explanation would be, I say, it's really potential that there's a filament moving up, like it's basically moving up in a chromosphere super fast. And it just happened like that. It took 5 minutes later, nothing was visible on the spectrum. So it's really, so you can basically analyze this kind of phenomenon with the software. If I fix the bugs, you should be. Okay, so someone was mentioning the jagged edge correction. So let me show you that in action. So I'm going to take a video that I took a few days ago. So this one, and I'm going to process that quick mode. All right, and we see the typical defect. So let's look at the non-modified version. So this is a typical defect that you see with the SAGs when the seeing is bad and that you have wind or you have a mount which is not moving at a constant rate or like oscillating, or you have bad seeing. So we call that jagged edges. And the software has some experimental correction for that. So in this case, you can go in the image enhancement and you can click this button. And if you reprocess this, it would basically try to fix this. So I say try to fix this because, as always, you should look at the result. And sometimes it's going to be good, sometimes it's not. But basically, it reduces the jagged edges. So it's still visible in this case, in this version. and yeah, there are some movements, so it was actually not that good for this particular case, but sometimes the results are quite impressive. So I encourage you to not check this by default, only use that if you see an improvement. And then there's this sigma factor that you can change. It's just going to use more or less samples to compute the correction to apply, if yeah, if it makes sense. So while I'm here, I can talk about other parameters which can be useful for you. So if you use the SAG 700, basically you should check this by default. So by default, when you run the software, it's no flat correction applied. And you can have some vignetting visible. So let's see if I reprocess this guy. I hope that this is going to be visible to you. Yeah, so you see that on the poles, it's a bit darker, right? And that's vignetting. And the software can fix that automatically if you go and select artificial flat correction. And in general, you don't have to change the parameters. You can try if you want to, but it should be good enough, at least for the SAG 700 with the default slit. And now that you talked about the 10mm slit now, I mean, I think that if you use the 10mm slit, then it's not going to be enough. And you will have to use the third strategy, which is a physical flat correction. And in this case, the idea would be to use the same kind of flats that you do with traditional solar images. So you basically put a cap with a diffuser in front, and then you point on the sun. You take a few SER frames, record the SER file, like 10 to 20 frames. Then you select that video, and it's going to create a real flat to do the correction, and then it would basically magically fix your vignetting issues. So you have the three options. For most people, artificial is enough with the SAG 700. If you use a JSolEx, usually you don't even need flat correction. Although in some cases, yeah, it's clearly visible. Like if you move to H beta, typically you have some vignetting visible. Especially in the center, it's much more clear than the edges. Then the second thing that you want to probably change is here in the observation details. So here you have the instrument that you want to use, and you can select between some different instruments. It's even compatible with the SenseScan. But if you have a custom instrument, you can create one. So you can actually go there and add your instrument. Like if you have a custom SAG, you can put the different parameters like the focal length of the camera, etc., the angle that is used, the grading that you're going to use, etc., etc. So you can create custom instruments there. So select the instrument. And then what is important here is to set the size of your pixels. If you don't do that, everything that I showed before regarding the detection of the phenomena is going to be wrong. Like the speeds which were displayed are not going to be valid. And the second aspect is that here in the process parameters, so far I've used this auto detect mechanism. So it's basically trying to figure out what you are observing. And it tries to do so by looking at the profile. But if your pixel size is not correct, then the dispersion, which is computed by the software, is going to be wrong. And then the profile is not going to be found correctly. So you can have errors. So typically, to illustrate that, I'm going to show you one more example, which is on helium line. So I'm going to go to helium and select a file, and I'm still selecting auto detect there. And I'm going to go with auto detection. Click with, so you see that it was not a good image in terms of how it was acquired. However, the result is still good. So doing so, it was able to detect that in this capture, you have typically here the sodium line, but up the sodium line, there's the the helium line, which is not visible to the human eye, just looking at this. like you would not see because it's an emission line. However, because we can compute the dispersion, if you have set this pixel size precisely, then the software can know that actually there's some data to extract. So you can look at the helium line there, and it's capable of generating this helium image directly without any processing. Like you don't have to tell it where the helium line is. If you were to, we could look at this video with the debugger, and we could go to the frames and go typically on the limb. And there, if you do that, you see that there's this line showing up. And this is where the helium line is actually. So it is something which is more visible on the limb. This one is clearly visible. But if you are in the middle, like you see nothing, like you would not see that. So I have a video tutorial to show you how you can try to generate helium line images on YouTube. But if you're interested, it's super easy to do with JSolEx. You basically take a capture where you have the sodium line or the ion line, which is just above, and you take that, capture that, and the software figure that out if and only if you have selected here auto detection and that you have here in the observation details the pixel size set properly. And again, we can look at the profile and then it would see that it matches. So it's a good hint. If you have the profile which doesn't match, then you have a problem. And that's why there's also this option to select the line manually if for some reason the software is not able to detect these lines properly. So a common mistake if you want to do helium line processing is that you choose helium there, like you will have helium. Don't do that. This would not work because this is just for colorization that you have the helium line there. What this corresponds to is the darkest line of your cropping window. So for helium, the darkest line is the sodium line, sodium D2. So that would be this line that you want to select. So if we do that and that we process, it would still be able to recognize that there's a helium line there. But in our case, auto detect was just good enough. Okay, so let's move on because yeah, we're still at 1 hour. All right, so in the tool menu, there are other things which can be useful for you to understand what you are doing. One thing that I like is the Spectrum browser. So there, you can basically select the instrument that you have, so Astro or Solex or whatever. You select that, and then it shows you the spectrum, and you can basically select a line, like what does the calcium line looks like, and then it moves to that. And then because you have this checkbox selected here, something that I often do when I'm searching for lines which are not super familiar, like I know if I need to search for this titanium line, good luck, like find that in SharpCap. So one idea would be to move this window on the left, and then you would have SharpCap on the right, or the other way around. And then you basically make sure that in SharpCap you have the scale to 1, like it should not be fit or zoom or whatever, like the ratio should be 1:1, and then you can put that side by side, and it helps you identify by scrolling basically where you are in the spectrum. So yeah, quite useful to learn about the spectrum. Like I don't know, you want to do some H beta imaging. Am I actually at the H beta 9 or not? Well, you can move that and put your image of the spectrum on the left and compare. And that's super convenient. And also, if you want to, you can colorize so that yeah, we'd see that it's in the blues part of the spectrum. So again, something which is usable for yeah, learning. I see. Oh, maybe there are more questions. Let's go to the chat. Sorry about that. I forgot to look at that. Okay. Nothing important right now. So what? It's not important questions, but I have to move on. So another tool which is useful is the optimal exposure calculator. So I would say it's less important with the SAG 700, but with SolEx it is quite nice because with the SAG basically we're going to have very, very short exposures, and often the limit is that you will have super high frequency, but the camera cannot deliver that. So the idea with this is basically you select your telescope, you select the instrument that you use, then you tell your pixel size and the binning that you're going to use, you tell which scan direction you're going to use, and the speed that you want to scan. So say I want to scan at 16 times a side reel, then it would tell me you need to have 265 frames per second in order to get a perfectly round disk. So that would be the FPS that you need to achieve. And often people ask me, well, actually, I tried that. I put my exposure at 377 and I didn't have a round disk. And often it's just because your camera cannot deliver this frame rate. So it's more important to actually focus on the frame rate than the exposure time, just for record. And yeah, so I don't have the calculator which does the opposite, which is actually to, given a frame rate, tell you what scan speed you should use. But yeah, there are scripts in ShortCap that you can use to have that if you want to. I know that Min has done something like that in one of these YouTube videos. So interesting, again, tooling for, yeah, for beginners, I would say. All right, yeah. Let me show you maybe another image now, just to illustrate something else. So I have here this H-alpha stack. So I have several images that I want to use there. And we can imagine that we have these created in a sequence in ShortCap in the same directory. So this is something which is actually happening often if you start your session and that you want to image the sun, then most likely you're going to have a few scans in the beginning, which are just to try to find the right parameters of exposure, the speed of the scan, the gain that you want to use, etc., etc. So a few of your frames are not going to be good, and yeah, it's a bit annoying because it's time consuming, and then you're starting to fill your disk with images that you will never use. So one option that you have there is to go and select the watch directory feature. And this is something I use every day, basically. So I'm going to select watch directory, and then we're going to create something which is just a test directory to simulate what would happen with SharpCap if I had new scans coming up. So I'm going with this test directory, select open, and now you see that in the bottom, JSolEx is watching. So it's watching for new files to ship into that directory. So now if I go there and I select my stack, and my first scan appears in that directory, there, so boom, SharpCap has written one file. It's going to show me a pop-up because it's the first scan, and that pop-up asks me for the parameters to process, and I'm going to choose quick mode. And I'm processing that, and okay, that's good. But let's say I'm not satisfied with the result because, I don't know, it's not perfectly round or whatever. I could click there directly on delete and delete that file, and then wait for the next one to proceed, and then it has deleted the file. So I can go into the next one, and it will appear in the directory. And then if you look at the logs, it's going to say, hey, I have seen a new file coming, showing up, and then boom, it processes the file automatically with the same parameters as before. So the first time it's going to ask you for the parameters, but then it's going to process with the same parameters again and again. So that's super interesting if you have a series of files and then you delete the files as they go. And once you're ready, then you can start your session. And then when the session is done, basically you have a list of files that you want to process, and you want to process them, for example, as a batch, but you want to process them fully, not just in the simple mode. So you can select the batch mode here, and you would go to this stack there and select these and say open, and then you would go with full process. So in this example, I'm not going to use full process. I'm going to use custom process just so that it's faster for the demonstration. I'm going to select just one image, the geometry corrected image, going to click OK, and then it's going to process all these images in sequence and generate the output. So this is typically where users stop with JSolEx. Like they use JSolEx in batch mode to generate a number of images, and they would go with these images into AutoStacker typically to generate some result. This is not what I do. So what I do is that I go down to stacking directly in JSolEx. But before I explain that, I need to explain probably the feature which is the most powerful in the software, which is custom scripting. And I'm not going to take too long because it is a huge topic. Like there's really a powerful scripting engine that you can use to generate some images, but I'm going to show you that in action just in a few comments to show you what you can do. So I have processed a file, and there I have this window here, which is showing me a script. So I can do something like image 0. And then I'm going to click run here, and I'm going to close the previous images so that it closes all these images. And the image that I'm showing here is actually the image which is processed, geometry corrected at 0 pixel shift, right? And if I do image -5, then what I'm asking JSolEx is to generate an image shifted by 5 pixels. And then we see something different, which is basically on the wings of the H alpha line. I can ask it to generate a range of images, like from -5 to 5. And then I click run, and it's going to generate a list of images in this case. Boom. So I have all these images from -5 to 5. But what if I want to generate an animation of that? Well, there's a function that you can use, which is animate. And then I'm going to click this. And now I have a video, which is playing this. But the image is dark, so maybe we should apply some stretching so that it's actually nicer. So in this case, I'm just going to extract this and give it a name. And I call it my range equals range. And then I'm going to say enhanced, and I'm going to use auto contrast. So that's the default strategy for JSolEx, my range. And it takes a parameter, which is the gamma. So don't focus on the syntax or whatever, it's just to show you what you can do if you learn this thing. And then I'm going to use animation of this, and I'm just going to add a section, say outputs. You say this is the only thing that I care about is the what is below, like the output section. Everything which is up is just temporary work for me to generate something. So now I do that. And it's encoding, and now we have this video, which is nicer to watch than these still images. And of course, so there are many different functions that you can use, like if you want to do, I don't know, some blurring or unsharp masking or whatever, this is available as functions in the software, in the scripts. And one of these is precisely what I use for stacking everything. So in this case, I'm going to select the batch mode and go to my stack, which is there. And I'm going to select, this time in the process parameters, in the custom process, I'm going to go here and select image math. And you have a list of sample scripts that you can use there. But in my case, I'm going to use a script that I created before, so it's quite large, but it is because it generates multiple images. But the idea is that when I do that, and I don't need to generate the other images. So it's going to take, I think, a couple minutes or whatever. So I don't know how much time it takes for you to actually create a stack of images. But for me, my time is precious. I need to develop JSolEx and I have work to do during the day. So I don't want to take too much time processing my images. So basically I wrote some scripts which I'm going to, which I used to actually have reproducible results. And so that's why I don't want to use Photoshop or whatever. I just want a script which is going to generate these images every time the same. So in this case, my script is going to generate an image which is stacked, but it's going to generate a stacked image also for Doppler, also for the eclipse, and for the continuum. And one thing that you cannot do, and that's important, one thing that you cannot do with AutoStackit typically is that in AutoStackit, if you want to stack on the continuum and that you want to stack the H alpha, in theory, the distortion is exactly the same between H alpha in the middle of the line and the continuum. But in practice, AutoStackit doesn't know that. So it's going to stack these differently. And it doesn't make sense because the distortion is exactly the same. So my script actually does that. So what it does is that it's going to use H alpha, which is more contrasted, to generate a distortion map. And then we reuse the same distortion map to rebuild an image in the continuum. So in this case, it means that the distortion that you're going to apply is going to be the same for the continuum image and H alpha. So it's going to be exactly what we want to see in the end. So while it's doing that, you can see that as the script is running, basically we have some images which are generated. So if I go there, we have all the different images that in this case are for the continuum, which are generated for each of the files. So you could decide to use these again directly in AutoStackit if you want to. I mean, you're not forced to use JSolEx to do the processing, but in my case, I have these images which are generated, and once this is completed, it's going to take all these images and stack them together. So we have the continuum image, but we also have, an image called blue, which is for the blue wing, one for red, which is the red wing, and then we're going to stack them again together using the same parameters as with H alpha and the continuum, so the same distortion map. And then you have something which is more correct, scientifically speaking, than trying to have something which, basically you would have to generate different images in AutoStackit. Like you would stack these and it would create one distortion map, and then you would stack the red one, it would create another distortion map, and then you would have to combine these images to generate a Doppler image, but the distortions would be different for the red and the blue wings, which doesn't make sense. So it's almost done now, and I guess, yeah, in just less than a couple minutes, it would have processed all these 7 files and generated my image. So in this case, I have this stacked image. And yeah, it's already fairly nice, I guess. And then we can click on this one, which is a version that is not produced by default by JSolEx, which is a contrast enhanced version. And the reason it's not, it's just because I use different techniques to enhance my image. So this is not something that typical JSolEx users would have, because the software that I presented in the beginning just creates a number of default images. But if you don't like them, you can create your own directly in a script. And that's what I'm doing here. So I could explain that to you if you go here and go to the Discord community. I could explain how the scripts are running, what they do exactly, etc., etc. By the way, there's a defect here, which is interesting. So if you see that on an image, this is a typical bending correction bug. So bending correction, the thing which is responsible for correcting the transversaliums, it has detected this dark line. It's darker just because there's a filament going on here. So it overcorrected these lines just because of the presence of a horizontal filament on the image. So the way to fix that would be to reduce the bandwidth correction, like to just one iteration, maybe reduce the width of correction, just to get rid, of that dust that I have in the slit. And yeah, so you have this, and then you have this inverse image, which I also do not generate by default, which is often super appealing. Like a friend is basically saying that you put any solar image in negative and suddenly it becomes nice, even if it was crap in the beginning. And then yeah, the prominence image, in this case, it's not super impressive, but maybe you can try to stretch a bit the parameters and see if it's better. If we have some signal, this guy, yeah, there's something here. So yeah, just basically what I wanted to show you, like if you want to, you can go down that route of having these images generated, stacked, everything directly in JSolEx. So no use of external software, whatever. And then basically just I think it's important to mention that for stacking in JSolEx, often people have some issues like say, oh, it creates some artifacts, whatever. Yeah, so it's basically the same in AutoStacker. If you don't choose the right sizes for the samples, or if you don't put enough samples, or if you have too many samples, then you would have some distortion, which is not nice. So in JSolEx, basically, you have two different parameters to tweak that. One is the tile size, and the other one is called sampling, and that's basically an overlap of the different tiles, and it would create a model of the distortion and try to morph the images together. And you have to adapt the tile size and the sampling to your images. It's important, otherwise you can have something which is not great. Okay, that's basically all I wanted to show you today for this intro. Let me show the questions, and I see that yeah, Min was tired, so we have to finish soon, I guess. Okay, so let me go with the questions, and yeah, if you want to unmute yourself and you have questions, don't hesitate. So this one
There
doesn't
are
say
a few questions by Pedro Ray. Where can you choose a script?
So where can I choose a script? So so there are some sample scripts that you have. So if you go, so there are different places, but the easiest is to go when you process something, you go to custom process, image math, and then here you have a list of sample scripts that you can use. So helium processing, continuum animation, creating a Doppler image, whatever. And the list depends on whether you're in batch mode or not. So if you go with the batch mode, you will have more sample scripts. So if I go there, like select the Doppler image, it would explain how you can generate a Doppler image, like how you create an eclipse on the technical card. So if I go with Eclipse, you would see typically that you have a function called disk fill, which is basically put that black disk on the disk, whatever. So you have some samples, and then the rest is basically you and me sharing these scripts on whatever you want. So it can be SolarChat, it can be AstroSurf or Discord, whatever. So usually when I do some processing like that, I share the script that I used, and I continuously change these. So yeah, that's why it becomes long, like because I'm doing it and say, oh, I need to create this image, and say, oh, it's nice, but now I want to have also the Doppler version, and then oh, okay, so how do you generate multiple images and whatnot? So yeah, there are many different options that you can use here in order to generate these. Okay, so can it do a magnetogram? Yes, in theory it can. In practice, I haven't tested because I don't have the data. But you would just do a script. And by the way, I can show you something fairly nice. If you have just a couple minutes, I can go to this guy. If I go, I need to find. So it was Sunday was 29, if I remember. Yeah, so I think it's 29. Right. So here I have a number of, see, quite large number of scans, and they were taken using JSol'Ex. So I'm going to process them in batch mode. So I need to go there, shortcut, so 29. So the line is iron line. So I'm going to take all these files. It's going to be fast. You see there are just 260 megabytes each. And I'm going to use, so first of all, I need to say that this is JSol'Ex. It's important because otherwise the dispersion is not going to be computed correctly. And it's pin 2, perfect, pixel size 2, 4. This guy, it doesn't matter. I'm going to remove this and use the Corona image and save that script. Let's save that in test files, demo, and we're going to say Corona. Okay. And so you see that there it has some functions, like it has some variables, like it tells you what is the reference line that I'm looking at, and then where's the ionized ion line, and plus continuum shift or whatever. So what it does, eventually it's going to generate an image of the solar corona. So that's something that I have seen at the JSON event in France, which was like 2 or 3 weeks ago, if I don't remember exactly. Nick was here, and basically there was Olivier Aguerre doing a demonstration of processing, well, actually showing how we can process different images of the solar corona. So you have to take 100 images, and then you have to stack them into AutoStracker. Well, actually, you have to use the script in serial in order to improve the contrast, then stack things together, then move the P angle so that the image is oriented correctly and whatnot. So it takes quite some time to generate this image. And with JSol'Ex, basically, in a couple of minutes, it's going to process all these 50 files, and we're going to have my first Corona image, which won't be great. It won't be awesome, but the signal is going to be visible. And maybe I can show you when it's processing what one image looks like. So this is one processed image, and you see that we have some whiter regions there, and this is actually signal from the corona. So it's super weak signal, so that's why we have to stack many different images in order to get the signal right. So basically, again, I'm using the batch mode just to generate the individual images, and then in the script there's a section which is just there in order to tell what to do once you have all these images, and basically it's stacking them together. Sorry, I thought it would be a bit faster, so I need a faster computer.
So can we, on the magnet, the e-corona, can we, overexpose the frame to show the link better?
So with JSol'Ex, basically, yeah, you would have to overexpose just a little bit the continuum. In my case, I probably did that a bit too much, like I overexposed too much, because in the beginning I wasn't finding any signal, and I realized I had to go in GIMP and tweak the levels and in order to find the signal somewhere, and I didn't have the function in JSol'Ex. So I basically added the function in JSol'Ex to do that automatically, to do the expansion of the very small range automatically. So yeah, so and I think to do that with the SAG 700, you would have yeah, you would have to, well, actually it's doable. I think you can do that, yeah. With the Corona, it should be better because you don't have this ND filter in the beginning, so it should cut less signal, and you can expose a bit more just at gain 0. So here we go, we have this Corona image.
Okay, so basically you overexpose the continuum, but you keep the exposure just enough so you can see the dark line of the iron line, right? So you can
So
have a reference.
if we go into and look at one of these, basically you have
Oh, I see.
So you see it's a bit overexposed. So in my case, it was too saturated in the center, so that's why it's not great result. But yeah, that's the first one I've done. So and the collimation was off and whatnot. So I think if you have this now, it opens a wide number of possibilities for SolEx users and SFV users to do this much more easily. So if you combine this with this, Solar, the Spectrum browser to find the line, because in the beginning it's not easy to find it, well, yeah, it becomes super easy to do so.
I actually had a couple of quick questions, Cedric. Can you hear me?
Yes,
I haven't used your software for a long time, so maybe my questions are a bit naive. But I was wondering, is there a way to call the executable from a command line, like in a Linux command line or a Windows CMD window? Because I know there's a couple of people who, like for example, like Jean-Francois, he has a script or something that does a scan and then generates an image right afterward. Um, so I was wondering, is that possible?
Yeah, so there's a scripting module. So it's basically you would not use the installer that I shown, but there's a different installer that, well, it's not an installer, it's basically the zip. You would take the zip and you have this scripting engine, and it's a command line tool, and then you could pass a script or whatever. So it's yeah, it's doable. Yeah, so if you're interested in that, just ping me and I can explain how to do that.
Okay, so that's a non-standard installation procedure then, rather than a feature. So you can't just like do a link or something to a executable exactly. You have to do it a bit more sophisticated. Okay, that's fine. And then the like other question I had was about the transversalium correction. I know that's from my own experience, it's a complicated thing, and you talked about banding. But one thing I found is that typically the way the transversalium correction works, it also operates on pixels which are outside the solar disk, right? So it tends to also cause a funny effect.
So actually
outside the disk.
Undercorrect on the outside.
Okay, so you do a sort of a cutoff. You do a cutoff at the solar disk so that it doesn't do I think it only really appears if you're looking at prominences and so on, but I didn't see too much of an effect outside your disk. So you actually do some sort of limit at the solar edge. Okay. Okay, great. I have some other questions for you, but they're more technical in like nature. So if you hang around after this, maybe we can chat about it. Yeah.
Yeah, sure.
Thanks.
Can I jump in, please?
Yeah, sure.
Yeah. You talked about the jagged edges, and I always have that because my mount, I have a very good mount, but it's not very good for scans, the Takashi. So I use a small one, a GTI, and I always have jagged mounts. If I use the corrected function for the jagged edges, of course, it has some influence on the resolution of the final image or not.
Yeah, so it does, but in practice, what I've seen is that it doesn't really reduce the resolution, because when you have the jagged edges, it means that you have problems anywhere on the disk in any case. Like it is shifted, and since you have a scan which takes a number of seconds, the jagged edge corrections, and that's also why I don't call that the turbulence correction. It's only some kind of cosmetic correction in any case. Like it cannot invent the details, like what was shifted in the perpendicular direction to the scan. So it cannot imagine that. So it's yeah, the principle is quite simple. It basically looks at the shape of the disk and what it should look like, and then applies some linear transformation. So that's why sometimes when you have some large prominences, adding this correction would not give you a good result, because it would disform the prominences.
But if I combine something like 20 images, it looks okay at the end.
Yes,
so and I always use the correction, and I always use your default parameter that's 2.5. So it works well.
Yeah. So you can do that, and then if you stack, I actually have evidence that the stack result is better if you do so.
Right.
The image is a bit more contrasted. Sorry.
Thank you. And another question, that's my final one. Does it matter to have a really round sun? Because it's very difficult to get it. So,
no. It's better to have one which is close to round. Perfect round is not great either, because if you have a perfect circle, you cannot basically find a tilt.
Right.
So it's better to have a slightly not round disk. But the closer it is, the better it is for the resolution.
I always have a rugby ball, so that's okay. Thank you. Very nice presentation. I will check the video later. Thank you.
Cedric, I would like to chime in. We talked earlier about the artifact from the overcorrected when you have big filament on the disk, right? It brought down the average, and it triggered the banding correction, right? So I'm just wondering if in the next version, could you please beside from the the scale of the correction, can you include
so we lost him for the suggestion. What's the suggestion?
So we can have more control.
Sorry, we lost you for the last 30 seconds.
Again, so for the banding correction, right?
Yep.
So if we have very big and dark filament on the disk, it would trigger the banding correction incorrectly, right? So what I'm asking is that is there a way to enable the user to have some control over the sigma clipping of the banding correction? Right?
Yeah, except that it doesn't work with sigma clipping. Like it is a very ad hoc algorithm that I use. So maybe for the sampling could do something. Yeah, I don't know. I would have to check what we can do.
So the easiest way would be, to reduce the scale of the banding correction, right? Because
the easiest is probably just to reduce the number of iterations and width. Because in general, you just have a small transversalium. Like the reason I have this parameter, which is here, sorry, like very large, is that when I got my initial JSol'Ex version, the slit was terrible. Like it had dust everywhere, and I had large bending everywhere. So I had to create an algorithm which would work in that situation. So that's the reason you have. But for most people, I think like doing something like 16 and one pass should be more than enough. And then I don't know, maybe we don't have the problem at all. So let's see. No, this is not the right.
No, not the one.
I don't know if it's the same. I would have to find which one it was. Maybe this one. You can see, but yeah, just change the parameters. Like play with the parameters, and you would this is the one. And you see,
it's gone.
We don't have the default. Yeah, so I don't think that we have to add more parameters. Just if we have to, I can think about that if we have to, but in general, I think that the current parameters are just good enough.
Okay.
Yeah, I can sort of mention, and maybe this also fits into something that Pedro was asking. In general, you want in all the whatever software you use, the minimum transversalium correction that gives you acceptable results, because the transversalium correction is some kind of filter in a way, and the more filter you use, the more adverse effects can happen always. So I would always do the very, very minimum that gets you the result. And in your particular slit you have, Pedro, the lines are your pieces of dust are so small that you just need the very minimum. And
I only have 2 now, and I'm not going to clean it. So
yeah, exactly.
It's perfect for focusing.
Exactly. Like I think I had a discussion with Min about actually putting artificial dust on the slit, because you can do
Yes.
lithography and you can
Yeah,
put little like lines.
I'm
And
considering that. I considering at submicron notch on the
yeah,
slit to add as focus.
yeah, exactly. There's sort of like a focusing tool of some sort. So I mean, there's some complications with that, I know, but as I said, in Pedro's case, he has almost the ideal amount of dust.
Right.
Cedric, a question on the Doppler eclipse images. Sometimes the area outside of the disk is completely blacked out, or even it shows occasionally a really dark blue, and you can't see the prominences. Any idea what causes that?
It's probably that I have to apply some curve transformation, and it has some defaults, and the defaults are probably not good in this case. And this is also where a script can help, because in this case you can basically use the script and tweak the parameters yourself. So because I could add more, parameters there, but I think it's already quite complicated what you have. Like, there are some parameters I didn't talk about in this presentation, like all these parameters there. So
I can do a run of maybe 8, and 2 of them will be no good. The rest will be fine.
So yeah, I would say if you have this situation, maybe try with a script to generate something. Maybe it would be better. And again, I can help if you have.
Or you can create your own custom mix with the Doppler disk and the Doppler eclipse. Just combine the two.
Yeah. Absolutely, yes.
Okay.
And it's the same here. You have, sharpening method. And by default, I don't recommend to add more sharpening, but some people want to have sharpening, so you can use that, and then you process, and the image would look better. But it's up to you to choose what you want to have as a result and share. So you see, eye appealing is something that is really, really dependent on the eye of the observer.
Actually, I had one more question for you, Cedric, and that is, I know that you put in the spectrometer parameters like grading, grading, and so on and so on, and then you do a kind of mathematical calculation of dispersion, right? Which you use for most cases, but do you also do a kind of actual dispersion calculation based on the spectral line database, or not?
So I'm doing the dispersion is computed based on the observed line. So if I'm in H alpha, so it's going to be 0.07. But if I choose a calcium image, typically the dispersion is going to be different, if that's the question. So if I do that, I'm going to see, no, it's 0.078. So
no, but I mean, is that dispersion based on the input parameters of the spectrometer, like the grading and the colorimeter and the pixel size, or is it based on actually measuring the distances between the spectral lines?
No. It's all based on the parameters that you put in the spectrograph. So it's based on these.
Yeah. Because my experience is that what I call the theoretical dispersion, based on the mathematical geometry of the spectrometer, is close, but it's off by a few percent. It's off by a few percent.
Yeah.
Mainly, I think, because the focal lengths of the lenses that you use aren't exact. Like you use a lens that's 100 millimeter in focal length. It's not really 100 millimeters. It's 102 or 105. So therefore, the calculated dispersion is, I think, good within 1 to 5%, but it's actually not exact when you compare it to the spectral lines.
If I may chime in, actually, the tolerance of the focal length of the lens manufacturer, because I'm working with the Chinese manufacturer, the tolerance is actually quite big. They have a 5% tolerance on the focal length. So for example, you get a 100 millimeter focal length doublet, right? It could be anywhere between, the 98 and 102 millimeter. So it varies in that range. So
yeah, I think that's.
But if you remember, I mean that's actually a story that we can tell. Like I mentioned that. So initially, when I got the SHG 700, I tried to do a helium line image, and I put in these parameters, like in the parameters there, I put what Min had said, which was that the SHG 700 was 75 focal length. And I got no helium image, like it was always wrong. So I had to change and move to 72, and then boom, I got the image because the spectral dispersion finally was right. And that's how we realized that your manufacturer had changed the focal length from the specs, like from 75 to 72, and then everything that you shipped was 72. But so basically, if it happens that you have a lens which is not 72 but 73 or whatever, you just go and create your own, and then the dispersion would be correct. So yeah.
Yeah, I think there's also some minor effects if the angle of the spectrometer isn't, I don't know, 30 degrees or whatever. That has a minor effect too. But I think the main effect is that the lenses aren't exact. Even if you use lenses made by Nikon or Pentax, they're not going to be exactly right in my experience. But as I mentioned, you have a way to exactly calibrate because you have a database, right? So you can, in every case, you could actually correct.
Like
as well for the area. Let's say you're near the sodium doublet, and there's plenty of lines there. You could actually exactly know what the dispersion is to know where the helium line is, if you see what I mean, rather than use the theoretical number, which.
But that's something that was actually used in the beginning. Like I didn't have the automatic like computation, and then you went there, and you could select the video. And then you would go and click on the line, and it would tell you exactly the number of points in average that where the line was. So that was the initial way to do the helium images. So you put the exact number of pixels. So the dispersion was not used in this case.
Right.
Any other question, guys? If you want to speak, just unmute your mic, and if no one has any other question, Cedric, would you mind?
If I can just ask one, sorry there. In terms of when doing the multiple scanning, I suppose one is how far do you slew past the edge to make sure you have no artifacts? And two, are you manually kind of using the controls to go over and back to the scanning, or do you have some scripts on your task?
I'm using scripts always. Like what I do nowadays, so it can change, but basically what I do is that so I'm using ShortCap with the ShortCap Pro, and then you can put scripts there, and then I have a script which basically tells the scanning speed and the time I want to scan, and so I just adapt that, and so I do a scan, and then it starts the recording automatically, stops it automatically, and then slews back. The issue is that with my mount, at least, so it's an EQ6, but when it slews back, it's never precise, like it never goes back at the right position. So in this case, just go and do one iteration only, and adapt manually with the command to it.
So Michael, on your question, I think I can have some information here. So you asked how much margin you have to keep on the side of the sun, so you can the scan the mount is scanning at the constant speed, right? So having the mount moving at the constant speed is very important because you are scanning across the sun, right? And you are recording. If you have the mount, speed up or slow down, so just as you do with a fax machine, right? If you have, pull the paper, you will have, the scan will go wrong. So, having how much, margin is depending on your mount. some mount have, big RA backlash, right? So you have to let the mount have the time to eat all the backlash on one side, and then you have some time to pick up the speed, right? Before it reach the disk, okay? And after it pick up the speed, for example, you pick 16 times serials slewing, right? And the mount has to have some time to pick up that speed before it is at constant 16 times serial speed across the sun.
Yeah.
So
make sure it's going at the full cut at the proper rate before it comes to the edge of the disk.
And on the other side, it's the same. You would have to let it clear the sun before you issue the stop command. So my recommendation is that you should exercise some more rather than less. If you have more margin, you only have bigger scan file size, right? But if you have too little space, you can have a squish or a non-round disk, because the scan size scan speed is not uniform, and that is a very serious problem. You cannot correct it post-processively, right? So yeah, that is the recommendation. Just put about.
And it's also a good idea to have some good margin in any case, not to cut the prominences. So
you can do some trial or see each mount is different. So
I'll try that. I've tried a small mount with a small telescope, but that was getting very jagged lame edges on that. So I'm trying a different setup at the moment. So I'm just waiting for some clear weather the next few days. Let's try again. Yeah, no, it's perfect. Thank you very much.
And most of the time, not only that the mount has to pick up the speed, but once the mount starts slewing, right, it has some vibration, some resonance, right, and you have to wait for the mount for that vibration to die down, and the mount is smooth slewing, right, and you can see that vibration very clearly. It's some wavy edge on the image, right, and if you see that, you know that the mount is vibrating. And you need to, back up a little bit more. Let the mount, let the vibration die down before you going in and for a smoother scan.
Perfect. Thank you very much.
Yeah, actually, one other issue is some mounts you'll only be able to scan in one direction.
That's my case.
Yeah, and so a lot of people, if they're stacking, they'll only stack frames that are taken in one direction and not either take data or they'll just toss out the data because their mount isn't.
The sign that you mentioned that the mount can only scan in one direction, right? It's a sign that tells you that maybe your mount balancing in the scan direction, like R, right? I think it is a sign that the balancing it needs a little bit tuning. Because when you especially warm gear mount, right, when you preload on one side of the gear, right, and you slew, it has some it has some vibration and resonance. So if you got better balance, you can maybe scan better from the other side. And one other thing is that if you have problems scanning in right ascension, maybe try doing in declination. Yeah, it should help, and especially on heavy loaded mount, and you have the SSG and the counterweight mount very far from the center of rotation. That will be the source for resonance because you have long arm of moment, right? So if you have that, you can scan in declination. You generally have very small moment of inertia in the declination plane, right? So it might be a good idea to try if you have bad scan in right ascension. Try in declination, and of course, always try to balance your gear. This is of course not applied to harmonic mounts. They actually slew better if unbalanced. But for warm mounts, warm gear mount, it is very important to have a balanced load.
My experience is that if it's slightly unbalanced in one direction, it is better. Because normally if I slew in another direction, it will be very bad, the ragged edges. But in the other end, no, I always scan in the same direction and with a little bit of unbalanced. So it works for me. But it depends on the mount, of course.
As I said earlier, if you have problems slewing, scanning in one direction than the other, then it is a sign that you have unbalanced mount. And it depends, It worth check the balance. But if your mount, for example, the Pedro use a very entry mount, so
the one I use is a very cheap one. You know that I have 2 paramounts, but I'm not going to use them to image with the SHG. They will get very hot, so it will. So I use another one. So
okay.
Thank you, Cedric. It was perfect.
Sure.
Okay.
The doubts I had were perfectly cleared. So thank you.
Excellent.
Any other question, guys? Anyone have question can just unmute your mic and ask it. Oh, Cedric, could you please go over the wavelength browser? I've never got that to work on my online setup.
Yes, I can show you that.
Go over that a little bit, maybe.
So this guy.
Yeah.
And you would basically choose. So you see the influence of so it is 1:1 ratio. So if you use a different instrument, you can see live that the slits are different, focal lengths are different, and things
this
like
is great for outreach. It's very easy to show all the lines.
Especially you can show like the colorized version. And,
yes.
See, oh, this is violet, whatever. And you can zoom out if you want to also. And oh, nice rainbow.
But I have never had, this the plate solving work. You have,
I have this identify thing, but it doesn't work great. So that's also why I don't insist on that. So sometimes you're lucky and it finds that. So basically the idea is to take a capture in SharpCap, like you take a snapshot, just a single image, 1:1, and then you give it to JSolEx and it tries to figure out where in the spectrum it is. And it's quite difficult to do so. So again, this is open source. So if you want to improve the algorithm,
ROI high, so we can have a more reliable plate solving identifier.
I don't think that it would matter in this case. Like a smaller is not better in this case. Like the larger, the better, because it has to figure out enough lines to find where in the spectrum it is. So in this case, if you take a snapshot, just take the full resolution of a camera.
Okay. Anyone else? Okay. I think if no one else has any more question, it's about 2 a.m. here, and my wife is getting really mad.
You have a couch, right?
I gotta go. I will transfer the host to Cedric, right? And if anyone wants to stay a little bit later and have a chat, you guys can, right? And I think I'm out for today. Thank you all.
Thanks a lot.
And I hope we can have another session maybe sometime in the future. Okay. Okay. Thank you. Thanks, Cedric. Thank everyone. Bye bye.
Yeah, Cedric.
Bye bye.
If you're around, Cedric, I just had a couple of other technical questions for you. Which not exactly maybe for general audience. But,
no worries.
But I was wondering, you're using cubic line fit, right, for the spectral line, and I think Inti is still using a quadratic line fit, isn't it? As far as I know.
Yes, but I changed that. So I was using cubic, and I found that it doesn't quite work. In particular in calcium, it gave wrong results. Like, sometimes the line was shaking, whatever. So so in theory it can do that, but in practice I reduced to quadratic.
To quadratic, yeah, because I thought okay, maybe the last polynomial was 0, but I saw on the screen
it's always 0.
Oh, it is, okay, because I saw three parameters, but the C is 0.
Yes.
Yeah,
yes.
Okay, because that was my question, because I know the limitations of cubic. I mean, I see the problems with cubic, so I was wondering whether you would changed to the traditional, like, quadratic. Yeah. Okay, yeah, if you do use cubic, I mean, in the software that I use myself, I use cubic, but it's and there is some possible mathematical reason why cubic is better, but I think it's very minor. But if you do use cubic, you have to take great care in order to use it. I was able to finally solve the problems with cubic, but it's not as robust, shall we say.
Yeah. The regression is problematic. As soon as you have one bad sample,
exactly. You'll have to be able to toss out the like outliers, or else it just goes crazy. Yeah. Okay. So like basically you gave up on cubic.
Yes. Okay. Well, it was working quite in most cases, but I had a few users reporting on some very low exposure. Like,
exactly.
It was super difficult to figure out, especially in calcium, because the line is super wide. So
okay.
So it was wrong. So
that was my question, because I briefly saw that you had three polynomials, but I didn't look at the values of the polynomial. Okay, that's great. And
there's something that you can do too. So I didn't show that, but you can select points manually and compute the polynomial if you want to.
Yeah. I mean, it was explained to me, like, again, by Jean-Pierre, that if the spectral line is extremely tilted, then a quadratic doesn't exactly work, right? If you have a spectral line that looks like that, then the quadratic works. So as long as it's more or less level, approximately. But as soon as if you get a situation which isn't very standard, you have to have a kind of camera rotation error. But if your camera is rotated, or your spectral line is very rotated, then cubic doesn't exactly quite work. But I think that's a bit of an edge. It's a bit of an edge case.
I think I could add a flag. I have some advanced parameters, so I could hide something to say, use third, or use whatever order. I mean,
you could use. It's possible, but then it's more complicated and more issues. And you're still writing in Java, is that right? It's really still J. Yeah, it's still like JSolEx with a Java.
That's the J for JSolEx. Yeah.
Exactly. And is it still open source? Like,
yes, it is.
So the source is still on the GitHub. Yeah.
Yes, it is. Yes.
Yeah. Okay. And I have one extremely technical question, and that is, how do you generate all of the targets? Like, you have a Linux target, you have like a Windows target, and because
I'm using GitHub Actions for that. I'm using GitHub Actions for that.
The GitHub Actions. Okay, I've never heard of that.
On GitHub, you can basically create some continuous integration pipelines if you want, and you can select what operating system you want. So basically, I'm generating a pipeline where I'm building for Windows, building for macOS, whatever. So different. So you just specify a matrix, and then you generate the combination.
Oh, okay. So you have GitHub actually generate all the executable code. Okay. I didn't know they could do that. Wow, I'm just such a novice.
Yeah. Otherwise, it would be so painful. I mean, I only have Linux. I don't have Windows or whatever. So even I don't have a Mac. So
yeah. Because I was doing my own executable using some, like, Python. What was it? Like like Python to Windows exe. But first of all, it wasn't very reliable because what would work in source code with this like Python script, I think, or like Python module wouldn't always work. Like it wasn't extremely reliable. And then I was thinking
Python in general is not super reliable for installers. Like the version numbers can be random. So.
Well, exactly. I mean, but for historical reasons, you know, because of Valerie and so on, then like a lot of the script was Python. But the like conversion to the executable targets was quite tricky. And I was wondering, how do you do it for like 4 different targets? Okay, so you use like GitHub.
Completely automated.
And it works, and like you don't even have to like debug. You know, like you assume that if it works in source code, it'll work in executable.
That's the advantage of Java, yes. That's a multi-platform language. So it's only the installer which can break.
No. It's that's what I mean is that the executables didn't always work. Like if I had, I mean Python is multi-platform, and okay, that generally always works if it's run in source. But I did notice that the target executables sometimes didn't work.
Well, there are some subtleties. Like typically for Linux, I'm only generating a Debian package. And, even for Debian, you have different versions, and some versions would not work, and that's why you have the zip version that you can.
Okay. I've noticed people who work in Linux generally use source code, so then it's not so relevant. Yeah, they're usually a little more sophisticated users.
Yes.
Yeah, exactly. Okay. Let me see if I had any other question.
Let me just ask another one.
Sure.
Please. When Min referred to the artificial flag correction, and then when you use it, and I also use that function, you shouldn't use the geometrical correction. Is that true, or you can use both?
You always have the geometrical correction, so I'm not sure what you mean by
that.
No,
the you have a tick for the orientation. Correct the orientation. If you correct the orientation,
no, you can use that. It should work.
Because he mentions in the video that you shouldn't do that, so I don't know.
Maybe I think I fixed that. I changed that for the I think I did that for the actual flat correction, like the physical flat correction. I changed how it worked.
But you also mentioned that with a longer focal length, it will be difficult to use the artificial flat. So you should do flats. So
yes.
Okay.
Yeah, I mean, just Pedro, I've used, I think, what was it? My longest focal length I used was maybe 1300 or no, 1200 focal length, and I used a slit that was, let's say, around 13 millimeters. So it was really close, actually. But there was a lot of vignetting which occurs within the optical system somewhere. Yeah, I think like you have to make everything in the whole spectrometer like with really big lenses, right? Because and the vignetting was pretty significant. I mean, reasonable quality, but the vignetting is really quite severe. And
but what do you recommend for the SHG? 500 or more? For the ones we have, the 700. 500?
So for the 700, I think you can go up to 700 without problem. And Min was saying that you can even go higher if you want to. It's just that
then you don't get the whole disc.
You don't get the full disc.
Yeah. I mean,
now with the new split, you could.
Yeah, I mean, the like limit is, and I think Min would agree with me if you were here, but okay. Historically, the JSol'Ex, the reason it had a 4.5 millimeter slit was because Christian Buell knew that the optics in the JSol'Ex wouldn't image correctly. Yeah, like they weren't, because it was a simple doublet, although not completely simple. They were. He actually did build a collimator, which I think used ED glass actually, but Anyway, there was a limit to the solar disk it could image, so he sort of put in this slit, 4.5 millimeters, I think, just to say, okay, guys, don't even try using focal lengths longer than this. And then I think JSolEx came out with recently like a longer slit, right?
Yes.
What is it? 6 millimeters?
7 millimeters, I think.
7 millimeters. And I haven't followed all the discussion, but I think on the JSol'Ex board, I think people complain about it a bit, because I think one of the reasons is it just won't really image up to 7 millimeters, right? Because the JSol'Ex optics,
there are two issues. So one is that you can't see the borders, so it makes the collimation harder to do.
Okay.
Because with the sensor, I mean, just doesn't fit.
Right.
And since you go higher in focal length, then you see the defects on the poles. Like it's blurry on the poles.
Yeah, and I think if you use like more sophisticated lenses, like I generally use like camera lenses, which are a little more sophisticated, and I think Min has got probably even a little bit more sophisticated lens, in the sense that he's able to get remarkably good resolution for a short focal length. Like typically it was 72, 75 millimeters, you wouldn't be able to image more than, just let me guess. So he's 72 millimeters. Normally, with that focal length, I wouldn't attempt more than about 400 or 500 millimeter telescope. But I think he's able to like do some correction. But I have my doubts whether you'll be able to image up to 900 millimeters.
Are you going to buy a SHC, Douglas, or no? You don't have one.
I don't have one. Probably not. I have enough of my own home built ones. I have about 4 or 5 home built ones. Probably not. I do know some people, by the way, like Ken Harrison. He bought the case basically. With the micrometers and so on, and then he put in his own lenses and grading, because he wanted a little bit, well, his own.
I know the micrometers help a lot, because it's very much easier to focus for sure.
Yeah, that's a pleasure to use.
Yeah. The micrometers is a very good idea, and I guess if he puts in some motors, it would be even better, right? That would be really good, because actually right now what I do is I actually like when I image from inside my house, right? And I have it kind of remote, right? I take the data like remotely, and I can adjust the telescope focus remotely,
right?
But I can't myself adjust any of the other things like the camera focus, right? Like remotely. It's not such a big disadvantage, but doing completely remote acquisition is much easier. Well, of course, Pedro, you're inside a dome, so you don't have so much of an issue, right?
But, exactly. But I do everything remotely, but for the deep sky, not for the sun, because I have to change everything all the time. But I'm inside a dome. It helps. It helps.
It helps.
And it's all,
Yeah, but like apart from not having like sun on your computer monitor, one thing I found with SHG is that the human presence causes some disturbance to the scan, right? I mean, if you just move around a little bit, in most normal cases, maybe not if you have a very good peer, but in most normal cases, like the ground will shift a little bit or the mount will start to move. So the human being next to the mount, I found, caused significant like vibrations and disturbances.
I also have trucks that pass nearby. Shake. Everything is shaking when they pass.
Exactly.
It's always a problem.
Yeah. So I found being remote actually improved the quality of the scans. Not, with my not being within 1 meter of it, actually improved the scans. So that's another reason why, like, remote control of all the lenses and so on would be actually, I think, quite helpful.
Yes.
Oh, but anyway, as I said, if you're talking about the SHG 700, or maybe it'll be called SHG 1000, I have my doubts whether with the current lenses of 72 millimeters, whether you'll be able to get above maybe 750, 800 millimeter focal length. I think above that, you're going to have to change the lenses to something, I think, longer focal length. Like, I actually asked Min this. I said, why don't you come out with a version with not only a longer slit, but longer focal length? But actually that generates a whole other series of questions, because then you need actually a larger grating, because the longer the focal length of the collimator, it means that the projected image of the slit on the grating is bigger. So then you have to increase the grating height as well.
All right.
So it all kind of leads into a series of problems. And then once you start increasing like the size of the grating and the length of the lenses, you have to increase the size of the case, and then you increase the mass. The mass of the case scales. I mean, the mass scales approximately with a cube of the linear dimension, approximately. Maybe like, I think I calculated it was about a factor of exponent of 2.5. So you increase the linear length a little bit, you increase the mass by a factor of exponent 2.5, and suddenly you're not able to fit it into a focuser anymore because it's too heavy.
Right.
So you start to generate all these effects once you start doing that. So honestly, I would say with the current SHG 700 design, I would say, like, don't expect to be able to image more than about maybe like 8 millimeters. Would be my guess. Even 7 millimeters, I think, is just pushing it from. I've sort of seen some of the images, and you can see with telescopes that are 700 millimeter focal length, you can see the edges aren't really quite as sharp. So.
Okay, we have to go.
Yeah.
It's dinner time now. and for Cedric, it's 1 more hour.
Yeah.
Okay, nice to see you guys.
Nice to see you. Yeah,
Thank you.
great. See you. Thanks.
Bye-bye. Thank you. See you.
Bye-bye. Bye.
Ciao.